Hello dear students. Here I prepare a review for the final exam. It is not exactly what you're going to have in the final exam, but it's an idea of how and what to study. The first thing that we studied during this semester or during the last part of the semester was solutions. Remember that solutions are made of solute and solvent. And don't confuse solvent with solution, because solution is a combination of these two things. For example, sucrose is a solute and is dissolved in water. At the end, what you have? No sugar, no water. You have a solution of sugar in water. The concentration of this solution is given by the ratio of the solute solvent. But here we have some examples of how can I ask you the concentration of a solution. For example, if it is about mass percent, is the mass of solute in 100 grams of solution, of course, multiplied by 100. If it is volume percent, it will be milliliter of solute per milliliter of solution times 100. And if it is the mass over volume percent concentration, it will be grams per milliliter of solution times 100. Remember that also we have molarity. Molarity is another expression of concentration. The molarity of a solution is the number of moles per liter of a solution. Let's write here the formula. Molarity is equal to moles over liter of solution. But how can you get the moles of solute? Sometimes they give you the mass, grams of solute, and then you divide this by the molar mass of the solute, and you get moles of solute. Here we have an example. Calculate the molarity of a solution that was made by dissolving 2.56 grams of sodium chloride in enough water to make 2 liters of solution. Then we have the volume of the solution. Look at this, it's always in liter. But they give you the mass of the solute. Then what you do? If you know that 1 mole of sodium chloride is 58.44 grams of sodium chloride, you can get the moles of sodium chloride. Then you divide the moles of sodium chloride by the volume in liter of solution, and you get the molarity. In this curve, that is a curve of solubility of a solution, you can find that all the points over the line represent saturated solutions. Which one are them? Are those that doesn't admit more solute to be dissolved in the solution. If you add just a gram or a grain of the solute, it will precipitate. In other words, an unsaturated solution is that solution that admits more solute to be dissolved at certain temperature. For example, at this temperature, you can add until here to get a saturated solution. But what about if you have a solution like this? In this point, you have a supersaturated solution. It has more solute that can be at this temperature. Then here you have a characteristic solubility curve and the three types of solution according with the saturation. But also we have another thing that is important in solutions, that are the tonicity. In this case, we are going to speak about the tonicity of a solution, talking about or related to a red cell. In a red cell, the concentration of sodium chloride is 0.9% and the concentration of glucose is 5%. All the solutions with higher concentration are hypertonic, and water by osmosis goes from high concentration to from low concentration to high concentration. And what happened in the red cell? Shrinkage. In the other hand, we have hypotonic solutions, solution with lower concentration than the red cell. Then what is going on? By osmosis, water will go in the cell, and the cell will increase the volume until produces hemolysis. It's very important for you to remember the concept of osmosis. Osmosis is the flow of solvent from low concentration to high concentration through a semi-permeable membrane, while dialysis is the movement of particles from high concentration of particles to low concentration through a semi-permeable membrane. Here we have the example of the dialysis bag that we made in the lab. The equilibrium constant is very important. Remember that a substance or a reaction is at equilibrium when you observe a double arrow system, because the rate of the forward reaction is the same of the backward reaction rate. Then, at this point, the constant of equilibrium, or Kc, is equal to the product of the concentration of the products raised to the coefficients divided by the product of the concentration of the reactant raised to the coefficients that they have in front in the chemical equation. The Le Chatelier principle expressed that when a change is imposed on a system at equilibrium, the equilibrium will shift to counteract the change, then try to reestablish the equilibrium. For example, if you add in this reaction chloride, the reaction will shift in the opposite direction to the products. But if you add copper chloride to negative, if you remove it, also will shift to the right to the products. Then it will go in the opposite direction of the action that is made. If you increase the concentration, the reaction will go in the opposite way. But if you decrease, it will go in the same direction of the reactant or product that is lower its concentration. Pressure. Well, the pressure and the volume are very important. Remember that the pressure is the opposite of the volume. If you increase the pressure, the volume will decrease, and the opposite. What you have to keep in mind is that when the volume is increased, the reaction will shift to the place where you have more moles of gases or solution in aqueous solution. Then, in this case, all are in the gas state. If I increase the volume, Well, you have more moles this way. If you increase the volume, the equilibrium will shift to the left. Same thing, if you increase the volume, then the pressure is decreased. And the opposite, if I decrease the volume, the pressure increases and the equilibrium will shift to where you have less moles. That will be to the products. The other thing that you have to take into account is the temperature. In this case, that you have the energy in the products. What does it mean? That you are releasing energy. Then this process is exothermic. Then you can say that this way the process will be exothermic, but the opposite reaction will be endothermic. When will be favor an exothermic reaction? If you decrease the temperature. When you will favor an endothermic reaction if you increase the temperature. In the case of the pH of a strong acid solution, remember that the concentration when you dissolve the acid, what you are going to have 100% ion, then the concentration of the acid is the same as the concentration of the hydronium ion in solution. And then you apply this formula and you get the pH, in this case is 1.3, that is acid because it's lower than 7. In the case of a pH of a strong base, well, it happens the same thing. The concentration of the base is the same concentration of the OH in the solution. Then you can say, as you have a 2 in here, then you have to multiply the concentration of the base by 2, and you get the concentration of the OH ion. And then you apply the formula. pOH is minus log the concentration of OH, and you get that the pOH is 1. If pOH is 1, applying this identity, you can get that the pH is 13. But if you are in front of a weak acid, then you are in an equilibrium. And what you have, that not all the concentration of the acid will be as the hydronium ion. They are different. How can you calculate the concentration of the hydronium ion? The concentration of the hydronium ion is calculated by this formula. Concentration of the hydronium ion in this case will be the square root of the constant of the acid times the concentration of the weak acid. Then when you have the concentration of the hydronium ion, you apply then the formula that pH is minus log the concentration of the hydronium ion, in this case this value, and you get the pH. This is for weak acid, and also it could be the same for weak bases. Let's continue then. Remember that an acid is that one that is a donor of proton. In this case, this proton is donor to water, and you get the hydronium ion. And then this weak acid